So here's the first problem. You're camping with your friends and decide to take a walk. You leave your campsite and walk 5 kilometers south, then 12 kilometers west. Calculate your displacement relative to your campsite. So the first thing you're going to have to do is draw a vector diagram. And a vector, remember, we represent just as an arrow. So here's my starting point. It's helpful to mark that clearly so you know which angle you're calculating if the problem gets a little complicated. And because you also, the displacement in this case will be from your starting point to where you ended up. So let's draw 5 kilometers south. The length of the arrow is going to be to represent its magnitude, how far it is in this case, and the arrowhead will indicate the direction. So there's 5 kilometers south, and now we'll do 12 kilometers west. 12 kilometers is going to be about 2.5 times 5. So I'm not going to take out a ruler and measure it. I'm going to try to be approximate though. I'm going to try to draw these proportionally. So this is 5 kilometers. You have to label these arrows. 12 kilometers, and your vector diagram is part of your grade on the problem. So it's also very useful to you in terms of solving the problem. So don't make this some kind of afterthought, some kind of squished up, messy thing that I can't understand and that you can't understand. Make it, give it some space on the paper here. So this isn't finished. In your vector diagram, you're going to have to include your unknowns. So I did this in a different color because I can on this thing. You could do it in a dotted line. This blue line here would be the displacement. Here's where you started. Here's where you ended up. This blue line would represent your displacement. And you also have to label that. So let me put an S there. That's my unknown. And I also have to find the angle. I know that I'm going to have to find the angle theta. Theta is going to be wherever it says relative to. After that, that's where you're going to put theta. So relative to your campsite, you're going to put theta right there. And in this case, your campsite was also your starting point. So I'm going to have to find this angle, and I'm going to have to find this displacement. And I'm also going to have to give direction. Well, what's the first thing I can do here to find my displacement? I can find its magnitude. So find the magnitude of the displacement. And that's what I'm going to do here. Well, how do I find the magnitude of this blue line here? This is a right triangle. I'm given 2 legs. I'm asked to find the hypotenuse. It's just a Pythagorean theorem problem. A squared plus b squared equals c squared. And s, the displacement here, would be c. It's the hypotenuse. So I know the hypotenuse is going to be the square root of the sum of the squares of the legs, the other 2 sides. So 12 squared plus 5 squared, take the square root of that, and you get 13 kilometers. So the magnitude of the displacement is 13 kilometers. I'm not done yet. I also have to find the angle. So I have to find theta. So when you're giving a displacement, it should allow relative to the campsite, your displacement will place you in one point in space and no other point in space. It doesn't leave any room for confusion about exactly where you are. So if we go for this magnitude of the displacement, and you say, well, I'm 13 kilometers from camp. This is camp right in the middle here. This dot, the starting point here, that's your camp. If you're 13 kilometers from camp, and if that's all you tell anybody, that places you anywhere on a circle with a 13 kilometer radius. So that's a lot of places you could be. So a displacement would give your position relative to camp. It would put you in one position and no other position. So that's why we're going to find this angle, and we're also going to give direction. So let's look at how we find this angle. We're going to need trigonometry. So the first step is going to be to identify these sides of the triangle. I know that the displacement was the hypotenuse. Here is the angle theta. And so this is going to be the adjacent. This 5 kilometers is going to be adjacent along with the hypotenuse. It makes up this angle theta. And if I go at the vertex of this angle and I go across, that would give me opposite. So I've labeled these 3 sides of the triangle. I don't want to use something that I calculated. I calculated that the hypotenuse was 13, but maybe I screwed that up. And so why carry that forward in another calculation if I don't have to? I was given this 12 and I was given this 5. I know they're right, so I want to use those in the next step. So what trig function has opposite and adjacent? We'll write out SOHCAHTOA. And it's the tangent function. that has opposite and adjacent in it. So my first step is going to be to write this out. Tangent theta is opposite over adjacent. I don't want to know the tangent of theta, I want to know theta. So I'm going to isolate that by taking the inverse tangent of both sides. And just be careful that you put opposite in the right place and adjacent in the right place. So this is going to be inverse tangent of 12/5. When I solve for that, I get 67 degrees. So I've found the magnitude, 13 kilometers, and I know theta is 67 degrees, but think about it. If you called someone and said, listen, I'm 13 kilometers away at 67 degrees, it would not tell you, or it would not tell them where you were. It would not put you at one point in space and no other point in space. So we need one more piece of information here, and that is going to be your direction relative to the campsite. So we're going to put your starting point, your reference point, right in the middle of these compass points, north, south, east, and west. So here's your starting point. It's right in the middle of the compass. I know that this is west, and I know that this is south. And so you could say southwest, but we can see here that there are two angles in the southwest. There's this blue angle, and then there's this one that I'll mark in pink here. So you can't just say I'm 13 kilometers away at 67 degrees southwest, because there are two angles that you could make that are 67 degrees in the southwest quadrant. So you want to specify that you're at this angle, this blue angle, that is the angle that you're giving them. So there is a difference between being south of west and west of south. And in this case, you would be west of south. To make this angle here, from south, you'd have to go west. So this would be a west of south angle, and that's the last piece of information you need. So what should your complete answer look like? You solve for S, you solve for displacement. It equals 13 kilometers at 67 degrees west of south. So here's the second problem. You leave home, you go 20 kilometers north, then 12 kilometers east, then 15 south, and finally 8 kilometers west. Determine your displacement. This problem is a lot easier if you take care to make sure that you're drawing this vector diagram neatly and try to draw it proportionally. So determine your displacement. It doesn't say relative to where, so we'll assume it's relative to your starting point. And let's draw this 20 kilometers north. So there's my starting point, 20 kilometers north and 12 kilometers east. So here's 20 kilometers. 12 kilometers is going to be less than that. So I'm going to try to, again, draw it proportionally. I'm not going to go crazy. 12 kilometers east, 15 kilometers south. So if this is 20, 15 is only going to be 3/4 of the way there. And finally, 8 kilometers west. So 8 kilometers is about 2/3 of 12. And so now let's label these things. This is 20 kilometers. Oops, let me get the squiggly line thing. This is 20 kilometers. This is 12 kilometers, 15 kilometers, and 8 kilometers. And now what is your displacement? In this case, it will be the distance from where you started to where you ended up and the direction. So that yellow line there is going to be your displacement. Well, how do you calculate that? We're going to have to look at these other sides. We're going to have to find a right triangle in here, and we're going to have to figure out the lengths of these sides. So let's see where our right triangle is. Let me get a different color here. Okay, I can have a right triangle right here. And can I figure out what the lengths of these sides are? Sure I can. So if this whole thing is 12, and then you only went back 8, that would make this 4. So this side of it, this leg of the triangle, would have a magnitude of 4 kilometers. And if this whole thing, here's your starting point, and you went up 20, but you only went back 15, we know that this side here would have a magnitude of 5. So we have a right triangle with legs 4 and 5, and we want to find the hypotenuse. We also are going to have to find an angle. Well, where are we going to put the angle? Where are we going to find theta? What angle are we supposed to calculate here? And that's why it's helpful to know what your reference point is. We're finding it relative to where you started. So I wrote this a little too small, but this is going to be theta right here. So I'm going to find theta. So I'll just do these things one at a time. I'll find the magnitude of the side. I'll find theta. And then I will find the direction. So let's take a look at this. First thing is going to be to find the magnitude of the displacement. Magnitude just means how much. So it's a right triangle. I'm going to find this yellow side, but we see this is a right triangle. We see that this yellow side, this displacement that I've labeled S, is opposite the right angle, so that's the hypotenuse. And we have legs of 4 and 5. So I know that the magnitude of the displacement is just going to be the square root of 5 squared plus 4 squared. And when I put that in a calculator, I get 6.4. Now I also need to find the angle theta. So what is theta going to be? Well, again, I calculated this S. I calculated the hypotenuse at 6.4, but I don't want to use that if I can help it. So here's my theta. The first step in finding theta is going to be to identify opposite, adjacent, and hypotenuse. So there's hypotenuse. If I go in this corner with theta and I go across, this 4 is opposite and this 5 is adjacent. So once again, you're using the tangent function. You want something, we're not going to use the hypotenuse because we calculated it and we know the 4 and 5 are right. So I'm going to use tangent theta is opposite over adjacent. I don't want to know the tangent of theta, I want to know theta. Theta is going to be the inverse tangent. Opposite over adjacent, I'm going to substitute. The opposite is 4 and adjacent is 5. And so for this, I would get 39 degrees. It's not enough to just say that, I'm 6.4 kilometers away at 39 degrees. There's a lot of 39 degrees. So we have to find the direction. So here is, we're going to put your reference point in the center of a compass. So here you are. You're finding everything relative to that point. I just colored it in green here. So we know that you're somewhere in the northeast here. Your displacement relative to home. In order to get to you, if you called home and said, come get me, they would have to travel northeast. And they would have to, and we found this pink angle here. So what we have to decide is that angle east of north or north of east? And in this case, it is east of north. From north, you would have to go east to make this angle. It's an east of north angle. So your whole answer would be displacement S is 6.4 kilometers at 39 degrees east of north. So here's the third problem. It's a little bit different. You take a bike ride and you end up 22 miles from home at an angle of 38 degrees north of west. How far did you travel in the northward direction? So here you're working backwards a little bit. You're actually given the displacement and asked to find some component of your total displacement. In this case, the northern portion of that displacement. So first things first, let's try to draw where you actually are. So here's the compass points, north, south, east, and west. This will be your starting point here in the middle. And we'll just label these. So you end up north of 38 degrees north of west. So here's west. To make this 38-degree angle from west, you'd have to go north. So you're going north of west. And that's where your 38-degree angle is going to be. So I'll make sure that I put that in the right place. Yeah, that's good enough. That's 38 degrees north of west. So that's the first thing you have to get right. It's really the hardest thing to get right here. And your displacement, the magnitude of your displacement is 22 miles. So once you get this far, it's not hard to get the rest of this right. You want to know how far did you travel in the northward direction. So this here is going to be your unknown. So I could have asked you, how far did you travel westward? And then you would have to find that base of this triangle here, but I didn't. I asked you how far did you travel northward. So you're going to find that that I labeled y here. You're going to find the magnitude of that component that I labeled y. So this is a trig problem. You're given one side of a triangle and one of the angles, and you're asked to find the other. This is a right angle right here. What function am I going to use? The first step is going to be to write down, what do I know? Here's my theta. I know that this is my 90-degree angle. 22 would be my hypotenuse. And if I go into this vertex here of this angle theta, y would be opposite. My unknown would be opposite. This side down here would be adjacent, but who cares? I'm not told what it is, and I'm not asked to find it. So I need a function that has opposite and hypotenuse in it. If I look at SOHCAHTOA, my memory aid here, I know that it is the sine function that has opposite and hypotenuse in it. So I'll write that out. Sine theta is opposite over hypotenuse. Which side am I looking for? I'm looking for opposite. This is my unknown. So in order to find that, I need to get it by itself on one side of the equal sign. I need to isolate that variable. So I'll show the steps here. You don't have to. Hopefully this is becoming a little bit easier for you. I'm going to multiply both sides by h. I'm going to write h over 1, which is the same as h. So you can see what's going on here. H over h is 1. So I end up with the opposite side equals hypotenuse times the sine of theta. I'm calling the opposite side y. The hypotenuse I'm told is 22, and theta I'm told is 38. When I punch that in a calculator, 22 sine 38, I get 13.5. And I need to put units, 13.5 miles, and this is the northern displacement. And here's the last problem. The grocery store is 5 miles due east of your home. You leave home and walk 4 miles north, then 10 miles east. Determine your displacement relative to the grocery store. So whenever it says relative to, that whatever comes after that is going to tell you where you're going to put your angle theta. And it tells you also where your starting point is going to be. So you're going to find the distance, the straight line distance from the grocery store to wherever you end up after this trip, and you're also going to find the direction. So let's take this one step at a time. First thing, we're going to draw a vector diagram. So here's your house. And I know relative to your house, the grocery store is 5 miles away. So let me put that in here, even though we don't need to know that quite yet. I'll make that a square so we know it's something different. And this is the grocery store. And this is 5 miles. So that's what I'm given. And I need this information because I start, and my distances, my initial distances that I travel are given relative to my home, but then I'm asked to find my final position relative to the grocery store, so I'm going to need to know this. Let's see, you leave and you walk 4 miles north, so we'll make some vector here, and we'll call that 4 miles. And then you walk 10 miles east. Well, if this distance is 5 miles, 10 miles is going to be twice as far. So I'm going to try to draw this line to be twice as long as the other one. And I'm going to label these. This is 10 miles, the entire vector here, and this is 4 miles. Right? I walked 4 miles north and 10 miles east. So determine your displacement. This is where you end up. You're right here, relative to the grocery store. So I want to know the straight line distance between where you ended up and the grocery store. So I'm going to label that. Let me draw that in here. This is the displacement I'm looking for. And I want to find a right triangle somewhere in here. So let me put in a right triangle, and hopefully you can see it. I can go right up here, and that can be one of the legs, and I can go across, and there's another leg. And I can see that this is my right angle here. And so remember that the reference point, in this case, relative to, tells me where theta is going to be. So I'm going to put theta here. Okay, theta is not going to be here. I'm not finding my final position relative to home. It's relative to the grocery store. This would be like calling someone at the grocery store and telling them from where they are, from that grocery store, how can they get to you? What is your position, and to put you at one point and no other point. So I have this green triangle here, but I need to know the lengths of these legs. So I know that this is a rectangle here, and this side is 4, so I know that this side is also 4. And I know that this entire top displacement here is 10 miles. Well, I know that the first 5 miles of that brought you just due north of the grocery store, so that the rest of this must also be 5 miles. So I have a right triangle with legs 4 and 5. So first thing I'm going to do is find the magnitude of the displacement. And this is just the Pythagorean theorem. I'm going to find the hypotenuse of a right triangle that has legs 4 and 5. And with that, I get 6.4 miles. So that's the magnitude of the displacement. So you could say, hey, I'm 6.4 miles from the grocery store. But again, just that information puts you anywhere on a circle with a radius of with the center of the grocery store and a radius of 6.4 miles. So it puts you in a lot of places. That's not putting you in one position and no other. So we have to keep going. Now I'm going to find theta. And it's the same thing, right? This is opposite and this is adjacent. So I'm going to use the tangent function again. Tangent theta is opposite over adjacent. Theta is going to be the inverse tangent. Opposite over adjacent, inverse tangent of 5/4, and that would be 51 degrees. So the last thing you want to do is find the direction. So again, I'm going to put my reference point, in this case the grocery store, in the middle of the compass. And you can clearly see that this being north and this being east, that relative to the grocery store, you'd have to head northeast. But I found this green angle, so I have to find out, well, how do I make this green angle? Is this east of north, or is it north of east? And clearly it is east of north. So your complete answer should be that your displacement, in this case relative to the grocery store, is 6.4 miles at 51 degrees east of north.